Hi everyone. Welcome back to my next session. So now I'll be sharing my screen. We'll put in a slideshow mode. In the last video, we just discussed about what is a biometric sensor. I already discussed. We are just going to discuss only about the fingerprint here, as well as we discussed what is pre-processing as well as what is post-processing. Pre-processing is the input that we are going to give. Post-processing is an output that we are going to establish or we are going to get. Okay. And then we discussed about what is image restoration. And in this video, we are just going to deeply discuss about the image restoration. I already discussed about what is image enhancement in the last session. What is image enhancement? If you're taking a particular image, whatever the important information we need, just we have to take that and we have to remove the unnecessary information. That is image enhancement. And in this video, we are just going to discuss about what is image negative, what is contrast stretching, as well as we are going to discuss about the histogram processing. Okay, what is image negative? Everyone know what is an image negative. We are going to take a input as through that input, we are going to convert the particular image into a negative image. So how this operation going to happen? So this operation going to happen by using a transform function. So initially, what kind of the image we are going to take? We are going to take a 2D image. So automatically, if I already discussed in the previous lectures, like if we're taking a 2D image, what is a function? What is an amplitude? What is a coordinate? We have to know everything. So if it is a 2D, we will be just having X and Y. And if it is a 3D, we'll be having X, comma, Y, comma, Z. So most probably, if you're taking an image, mainly we will be concentrating on the 2D only because always we'll be concentrating on the binary images. So if you are moving to the some advancements only, we'll be taking a 3D image. Now you can look into this image. This is the original image and I converted that into a what? Black and white image. I mean, dark image or image negatives or something. How this operation happened. So now look into this. So this is known as a transform function. So that is what it was represented as a T. And f of x comma y. So f of x comma y is a original image. So I'm going to convert that into a what? Image negatives. So g of x comma y, that will be represented as an image negative. Formula for that is that I'm going to take a original image and I'm going to convert that into a image negative. For that, minus f of x comma y. So t represents a original, I mean transform function. How the transform function is going to happen? This f of x comma y, that is represented as a original image. By applying the transform function, I'm converting the original image into a image negative. So g of x comma y equal to t minus f of x comma y. So this formula is used to convert the original image into the image negative. So this is going to happen like this. Next, we can go into the contrast stretching. So what is contrast stretching means? If you're taking a particular image, that image should not be a light image, as well as that image should not be a dark image. So you can look into this first image. So the image is very light. You can look into the second image. The image is very dark. So automatically the resultant will be histogram is not equalized in both of the images. So automatically we will be facing a problem while you are dealing out with this particular image. So to overcome this, what you have to do is that we have to always specify a image that should be have a histogram equalization. Now you can look into this first image. So this is a dark image. So this is little bit dark and this is a bright image. So both result in a not equalized state. So if you take out this image is very dark, but you can look into this image. So this is an equalized image. I can look into the wall that is of black color and I can look into the thread. and I can look into some objects. I mean, in the edge, there is some particular what, like how we can say, there is some, how we can say exactly, there is some equipment is there, like that we can say. So that's what we'll be mentioning as an edge detection. So what is the most important thing is that, so whatever the image that you are going to take, that should be, so automatically, if you take out this image will be represented as a dark. And you can look into this image that is known as a bright. This is known as the low contrast image. So this is the high contrast image will be the image which is operated right now. So I'll be giving the deep explanation while I'm moving into the histogram equalization. Now we can move into the removing the specular highlights. So for this, I already said that I'm just going to cover with a finger here. But wherever we get an opportunity, I'll be explaining about the other traits. So now this is the example of the retina. So now you are taking a retina as an example. I already said many times, retina will be preferred for all the peoples except the blind people. So I'm capturing the entire image of the eye. So what I'm applying here is an image enhancement. The thing is that I just need an important information. For for iris, I just need a retina. So what other things I have to remove it? So only the eyebrows and retina is needed for this. So what I have to do is that I have to remove the remaining things. So what is the image enhancement definition? What is the most important information that we need? Only we have to take it, and remaining unnecessary information we have to remove it. So I removed it. So as well as what I said, if there is any, while I'm processing it, if there is any what if there is any quality of the image is not good, what you have to do is that we have to remove it. For that, I have to apply a technique called image degradation that we will be discussing further in this slide. So there is some image degradation. How this image degradation occurs? There is some retina is here. There is some retina. Inside the retina, while I'm capturing the photo of the retina, there is some light falls on the retina. So I have to remove that. So for removing that, I'll be using the image degradation technique. So by using the image degradation, that light particle appears in the retina will be removed. So this is known as the removing the specular highlights. I'm just going to take out on input. I just need a retina. For that, I'm going to use an image enhancement. I'm just taking out and whichever the important information needed for the particular input, only I'm taking it and removing the unnecessary information. After removing the unnecessary information, there is some light particle appears in the retina. For removing that, I'll be using the image degradation. So there will be some formula for the image degradation. We'll be discussing that in the further slide. So after applying the image degradation, that light particle appears in the retina will be removed. So this is the pre-processing and this is the post-processing. So next we'll be discussing about the region of the interest. I already said. So this is about the remaining trait. So I said about the only finger we are going to discuss. Already we discussed about the finger and we discussed about the iris. Now we are moving into the hand geometry. So hand geometry means this entire region will be captured. Here, exactly which is region needed, only that will be taken and remaining will be discarded. So whichever the region that we are taking, for that the formula will be the region of the interest equal to 1. That will be represented as a true. The remaining things that will be discarded. So that will be represented as a 0. For discarding that, we'll be using the image degradation process. That's what I said then. So whatever the traits that we are using it, we are using it. What we'll be doing is that in case if certain things is not needed, we'll be using the image degradation process. As well as if the quality is not good, in that there also will be using the image degradation process. So image restoration. So image restoration means, so this is the input image that we are going to take. So the quality of the image is not good. What we are going to do is that we are going to apply the image restoration. Image degradation process, or else what we can say is that image enhances process. So through that, what we are doing, we are going to improve the quality of the image. So for that, whichever the image quality is not good, we are going to apply the degradation process. So by applying the degradation process, so the image quality will be improved. So automatically the image clarity is improved. So next, in the next lecture, we'll be discussing about the how this image restoration process is going to happen. There is some formula. We can discuss that deep in the next lecture. So in this video, we discussed about what is image degradation process and how the histogram equalization going to happen, and whatever the input that we are going to take, that should be a equalized input. It should not be a bright or dark. Whatever the image that we are taking, that should be a equalized image. So in the next video, I mean in the next lecture, we can discuss deep about image restoration. Now we'll be stop sharing it.